Lesson 90 is about measuring turns, and this is a very important lesson, especially if you do any navigation with something like a compass or a GPS, because you've got to use those tools to help you figure out where you're going. Now, our first question says, Leela was traveling north. At the light, she turned 90 degrees to the left and traveled back 1 block to the next intersection. At the intersection, she turned 90 degrees to the left. What direction was she facing? So when we're measuring turns, we're going to use a compass rose just like we see on a map, and the compass rose is going to have north going up, and then it's going to have east to the right, south going down, and west to the left. Never eat soggy worms. That's one way you could remember it. Or you could just remember north, east, south, and west. So, Leela was traveling north. So Leela was going north. So she was headed north at first. Okay, so she's going north. At the light, she turned 90 degrees to the left. Now we know 90 degrees makes a right angle. So she turned 90 degrees to the left. So she's going to be traveling this direction. She traveled back 1 block to the next intersection. So here, in this direction, she's going west. At the intersection, she turned 90 degrees to the left. What direction was she facing? So if she went here, 90 degrees, we'll make our box to show it's 90 degrees. And then she turned to the left again, so she was heading in this direction and she turned left. She must be now going in this direction or looking in this direction. What direction was she facing? Down. On our compass rose on a flat map, that's always south. So our answer is south. And we've done that by measuring the turns, going from the information from the question. We can go ahead and write it out, south. And we want to write out south rather than S, because an S could look like a 5, and we've got to make sure that we talk about a direction in this problem, so we'll just write out south for our answer. Let's look at our next example. Actually, let's copy our compass rose first before we go on, so that we can use it to help us find our next answer, if we need to. Andy and Barney were facing north. Andy made a quarter turn, 90 degrees, clockwise to face east, while Barney turned counterclockwise to face east. How many degrees did Barney turn? Let's put that compass rose back in here. So, Andy and Barney were both facing north. Okay, if they were both facing north, here we'll have Andy, here we'll have Barney. They're both facing north. Andy made a quarter turn clockwise to face east. So clockwise, a clock will run around like this. So if he makes a 90-degree turn, he's now going to be facing to the right, which is the east. While Barney turned counterclockwise to face east. Well, to turn counterclockwise, you must be moving in the opposite direction. Counterclockwise, the opposite way of an analog clock. So if Barney did that, if Barney turned, well, he turned from here and he went all the way around to get to this point. He went all the way around this way, like that. Andy, he was a little bit more efficient. He just went like that. Well, if Andy, and actually with that last one, let's go ahead and put that symbol underneath. So Andy, he traveled 90 degrees to face east. We know that each quarter turn is 90 degrees, so Barney made 3 quarter turns to go from north to west to south to east. So 3 quarter turns, 3 times 90. Well, we know that 3 times 9 is 27. We've got a 0 because it's 90 and not 9, so it must be 270 degrees. So we've got our answer. Barney turned 270 degrees to face the east. Why Barney did that? I don't know. He could have just turned the other way and only turned 90, but he decided to turn all the way around. Maybe there was a good view over here that he wanted to see before he settled on his direction to the east. We don't know, but we do know that he turned 270 degrees. Let's look at our next problem. We've got one more in our lesson today. As Elizabeth ran each lap around the park, she made 6 turns to the left and no turns to the right. What was the average number of degrees of each turn? So in this problem, let's use our tool here that we have to form a 6-sided shape. Do you remember what a 6-sided shape is called? Hopefully you do. Remember, a six-sided shape is called a hexagon. So we've got our hexagon here, a six-sided shape. So Elizabeth ran each lap around the park. She made 6 turns to the left and no turns to the right. What was the average number of degrees of each turn? Well, if we look at this, the park, we don't know what shape it is. But what we do know is that Elizabeth ended up going in a big circle because she started at one point. We're going to call our beginning this point. This is where she started, and that's where she finished because she turned to the left each time. So she ran in this direction. So she's always turning left. We know that if we were to draw a circle on the inside of this picture and connect it to the outside, that we'd have a total of 360 degrees that she traveled. Now, she traveled 360 degrees total because she started and finished at the same spot. So she traveled 360 degrees, and she turned how many times? Well, it said she turned 6 times. So she turned 6 times. So what we have to do is we have to break 360 into 6 equal parts to figure out the average number of degrees of each turn. So 360 divided by 6. 6 goes into 36 6 times. That's 36 with 0 left over, so our other 0 has to come up. She traveled an average of 60 degrees each turn. Now, we could box that, but before we move on to our next question, we'd want to make sure that seems reasonable. So if we look at each turn, each degree turn, like in the middle or the inside here, if we looked at those, each one of those seems like an obtuse angle. So it should be bigger than 60 degrees. But if we think about where she's actually turning, she is turning in a different manner. Let's back up. If you had those on your page, you may leave them. You don't need to erase them. But when she runs, she's running in a straight line. So if she were to continue her straight line from where she started, she would have gone off like this. So her first turn wasn't on the inside, it's actually this measurement, from here to here. And we can see that's definitely an acute angle. That looks like 60 degrees. Our next turn, well, she would have been going straight here, but she turned again. We've got another acute angle, so that's also approximately 60 degrees. Our math is correct. 60 degrees looks reasonable based on our picture and the information we're given in our problem. We can move on to the next question. Lesson practice will be on page 481. If you have any questions, please go ahead and write them down. Make sure you've got your notes completed, and I'll see you during our next class.